Yep, we are back. It's the new grind 75. Alright, that grind is not mine. Again. Now, middle of the linked list. We need to find. I believe this should be the easy one. Middle of a linked list. Given a head of a single linked list, return the middle of the linked list. Most probably you can do. Okay, it's asking the middle of the linked list means if there are two middle nodes and return the second middle node. Okay, trying to say if the number of nodes are even, right? Given the head of a single list, return the middle node of the linked list. All right. List node. Slow, fast, both will be equal to head. Equal to head. Now, while fast next slow equals slow next and fast equals fast next and I'll just return slow, but if it is given as even, if the length is given as even, then I'll have to 1 2 3. One means pod, 2 means a node, okay, like this I can do a workaround. Tool even false I mean, after doing all this, if fast next is there, okay, if fast next is there, but fast next and fast next is already verified, and yeah, we're back. So we have this boolean fast next is there, like if fast has not completed the array, but next I mean there's only one node is left doing everything. Yeah, so if there's only one node left, and maybe I should place it before, right? Yeah, I should place it before. and equals true, and if it is even, right, we'll be doing even question mark, then slow next or slow. I hope I'm not over engineering the solution. Yep, let's see. That's nast. Okay. Fast. Let's sit for next. Oh, it is already. Yep. Let's look at fast only then. We got it. Expected is 4, 5, 6, but we are getting 5 and 6. 1 to 2. Fast is here. Okay. This is an even. So this, and this. Fast is equal to 3. And fast is equal to 5. So 1 to 2, 2 to 3. But now you cannot go any further, right? So, but you have. One loop was there. Let me remove this thing. This even in the over engineered solution. Okay, let's do this. Let's try to submit it. Yeah, it worked. Fine. Doing the question. Maximum depth of a binary tree. I wonder how I'll be doing it. The binary tree's maximum depth is the number of nodes along the longest path from the root into the farthest leaf node. I think this also I'll analyze. Now let's do this. Int answer equals 0. DFS return answer. DFS of root comma answer, and yeah. Int DFS tree node root turn 0, and try to go to the deepest. We'll try to go to the deepest, right? So int left equals DFS of root left, int right equals DFS of root right. Now we have left and right. then we are going down and down and down each time. And we have answer. We'll be passing answer, we'll be passing along answer, and here answer will be equal to max of answer, comma max of left, comma right. Return answer. Let's see. I think this is wrong, but wrong, but can be correct if I. How can I justify it? Let me just run it. Let's say that I can justify it if I would have done my homework over the other question. Okay, 0, 0. I mean, max of max of answer, comma plus max of answer. Let me think about it. Just give me some seconds. So this is the solution which I've done last time, and where we are finding out the longest path between given two nodes, right? Given in a tree between two nodes, which was diameter of a binary tree. Here we are getting, like you can say, we are getting here this one as the when we are doing value max of value comma left comma right. This part is not necessary for us, but this part is. Okay, so we have to do this one plus max of left comma right. All right, let's try to do it. 1 plus max of left comma right, and answer equals this, and answer should be should be nothing. I guess I can delete this one. Need to analyze. That's what I have got. Like this question should have been this question should have came before the other diameter question. I believe that would have been better. And let's try this. Maybe see if I do in a way like if I do this using stack, maybe then I'll be able to get more right. So let me make a note. Analyze diameter for binary tree. Also depth of so max depth of a binary tree. Next, what should what should we doing here? Should we be doing here is a tree solution of trees. Okay, so these two things and another one. Let me point it out as and try to implement them in active way. Okay, so these two things we'll be doing. This is done. Let's check another question. This one is done. Contains duplicate. Okay. Now there's only medium question, and then weak it is hard question. Okay. All right. Contains duplicate. Given integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Saying given an integer array nums, return true if any value appears at least twice in the array. Return if the element is distinct. I think there are multiple ways we can do this. Like we can use map, okay, and we can use set, like size of array is equals to size of set, then we will return false, and that will take a long time. Is there any other way we can find out? N-square way I think got that. I can also sort an array, right? Using a set and a hash map will be order of one work, right? If another set or another hash map is being used. But if I use, you say, how can I do it in order of one space? I mean, O of one time complexity is fine. I mean, O of n time complexity is fine. O of one space, is there any way? Well, let me just think about it. If we can do it like that. O of one space. O of one space. Hey, nice little feature here. I like it. Okay, so O of one space. If we use two pointer and given a window, we'll see one is not there, two is there, and one and two are different, then two and three are different, but I haven't compared to one yet. So let me see the discussion here. It's a the time to consider. Okay, And risk that I submitted the same solution multiple times. The runtime varies a lot. Okay, leave it. You can solve it n time without using any extra memory. That is no hash set or a dictionary, not yeah, this is what I wanted. Not much if you let it sort it. Like, the sorting of the replies are very weird. I guess it depends on the date or time. The probably with some form of sorting, if you could sort the array, duplicates should be next to each other, but it depends on sort operation, how much memory. Nah, bro. In place sorting algorithm is there. We are not even talking about the RAM. For anyone wondering, it is particularly using bitwise operations only if there are even number of duplicates. Okay. Here is a similar problem which can be modified to this. XOR, bitwise operations. With the number of yeah, got the point. So XORing outright, just trying to say. Okay. Yeah, this is fine. M block 6 complexity we need M, right? So to find the size of array nums is used to take the linear times over complexity. What the So no one is doing it in order of n and order of one space, order of n time. I think it does not. This guy has done 100 days, right? So we'll add this to the list. Contains duplicate. We need to check. And of 1 space solution ext exists. We'll do it in some time today only. Now let's implement the solution. Return to else, return, else will just be placing it m of x equals, we can just do boolean. That is fine, if we can do it. Return false. Oh, sorry. Okay, what is the top 100%? That was funny. Okay. What kind of C++ code is this? Okay, I can leave this. I'll leave it. Contains duplicate is done. Next in maximum subarray dp. I'll just 29 minutes only, right? You can look at it, right? Maximum subarray. Given integer renums, find the subarray with the largest sum and return its sum. This contains non-empty sequence of elements within an array. Largest sum continuous, it is asking. Otherwise I could have like used cadence algorithm, right, to find this. But as it is subarray and continuous, maybe not. No. How to solve it? as it is saying, it is a dynamic programming question. Dynamic programming question by definition can be subdivided into optimal and overlapping subproblems, right? Divide and conquer, dynamic programming. Array. Input given as this, input given as that, and this. I need to analyze this one. I can see n square solution here. Yep, because this is subarray, right? So n square solution I can see, but to reduce it, how can you subdivide it into a smaller problems chunk? If I have sum of first two elements, do I need to check for the sub of, like, do I need to do the sum of next three elements again? No, I can use the last two elements sum and next element I can use it. That way I can say we can use a dynamic programming approach. What else can we do here? 5, 4, 1, 7, 8. Let's go to first one. So minus 2, 1 into minus 1, then minus 1, minus 3 into minus 4. Yeah, let's start. So we have this array minus 2 comma 1 comma minus 3 comma 4 comma minus 1 comma 2 comma 1 comma minus 5 comma 4. And how can we start summing it out? How can I use dp in this one? That we need to know. In DNC, see, it is also saying divide and conquer. In DAC, first step is divide, second step is merge, and I actually forgot what are those two steps, but yeah, DAC. Now, if we divide it to some problems, suppose we divide it to this small array, then this small array, then this small, this and this. Then we'll be combine these two. Then we'll be combining this two, and we'll be combining this two. Check which one is greater. So 2 minus 1 is going to be minus 1, right? And minus 3 and 4 is going to be minus 1 again. So we'll remove this part, we'll keep this part, we'll next two, okay. But this is not overlapping, we need to overlap. This will not work, honestly. Have I done this problem already? Is it saying solved? No, it is not. Maximum subarray. Can I check this question without looking at the solution? Here. Oh. Wait, this is not that problem, right? Okay. Okay. That's crazy. My god. it is cadence, then maybe I can do this. Uh, int answer equals 0. Int min and for int x int x of nonce. T plus equals x. Answer should be equals to max of answer comma t, and here okay, it is asking for that. Fine. This solution is for sure not complete. Cadence algorithm, do not remember, but it is something like we'll add this -2 to this 1, and we got -1 as answer. That is fine. Answer should remain 0. Maybe. Let's see. And this is -1, then -1 goes to -3. So we know that -1 is going to be not the -1, like -2 is there, right? So -2, then 1. So 1 is going to be the answer. That -2 minus 1 goes to what we say is 0, so that we can give the next element a chance. So if I have t as negative, before going to the next element, I would like to make it next element, I would like to make it as a 0. So yeah, if t is less than 0, then t should be 0, and answer would be the least negative number. Yeah, I believe this should work. Yep, it did, and it should work for all the cases. Yeah, now see, a little bit of speaking goes a long way, so I am glad like I have spoken. Now they are saying cadence algorithm is fine. I would like to do it in DP manner as well as DP as well as TNC, divide and conquer. So we'll stop it here. In next video maybe we can try, or maybe in this one only, right? Let's try it in this one. Let me pause it, take a break for 10 minutes. I'll come back. So I'm back, have seen some solution, but I have not like looked into code deeply. I'm just looking at I've like created a relation like to understand further DP problems. I need to understand the recursive solution, and recursive solution is actually based on the logic of we can say brute force maybe. So we can start one by one looking at it, and after that we can start with this dynamic programming, and then we can go with this tabulation method. Like one dynamic programming is done with you can say recursive programming in mind, like overlapping problems they have reduced, overlapping calculation. So first, actually, what we need to understand is how they have approached the solution such that they are able to get this overlapping problems. So that we'll analyze first, and later we can look at this class solution. Yeah, we can look at this tabulation method. That would be very much similar. Then later we can go to this we have already done and got the solution, like how it is happening, and at last we can go to this divide and conquer. And I don't know about this optimized one, but I'll take my good time to breeze through all of this and find if there's any better solution or anything. But today, without any help of any teacher or any video, I'll try to finish it. Give me just a few more minutes. I'll start. Yes, I'm back, and let's check out the solutions which are mentioned here. So brute force. Yeah, we can check brute force like they're going in this for loop, and then after inside this for loop. Why my cursor is lagging so much? Let me see. Okay, by trackpad it is working fine, but my mouse is lagging for some reason. Alright. Using. Okay, I can work with it. So yeah, we have this brute force thing. Let's analyze this one. Nothing to analyze, but still, yeah. So brute force is here. Let's do the brute force quickly. So we are trying to find the maximum subarray. So it will start from I, and suppose this is the array 1, 2, 3, 4, 5, and 6. Let's start from this and continuously add everything. And each step it will try to take the max of it, and this max will be universal. Next will start from here. Next loop will start, sub loop will start from here. So this will be n into n into 1, you can say. First last loop will run one time, second last loop will run two times, third last loop third last loop will run three times, and so on. First loop will run for n times. So this is like n into n minus 1 by 2, that is n square time complexity. And yeah, that is it. We can look at, I'll not look at, we'll try to figure out the recursive approach. So suppose given this array, let me take it from here. Given this array, approach, given this array, so in recursive we can do permutation and combinations, like it can be either we take this element, it is something like that, either we take this element or we do not take this element. Okay, then if we take this element, next all element should be taken, right? This, then this, then this, and all of them, right? Suppose if we leave this element, okay, then we take this one, means upcoming all the elements needs to be taken. Similarly, like we can keep a variable like this one answer to store the maximum value. And suppose we are starting from 3, we are deciding either we keep this element or we don't keep this element. Now this is what my understanding is. Let's see, check out the code, solution code. So here recursion is saying another way to consider every subarray and return the one that has maximum sum is using recursive approach. Here we can state the approach as, at each index I, we can either pick that element or not pick it. Yeah, correct. If we pick the current element, then all future element must be picked. Since that is the reason. Yeah, I was also saying, like we need to pick all other elements because it is contiguous and basically subarray, right? So if we had picked any element till now, we can either end further recursion at any time by returning some form till now, or we can choose current element and recurse further. This denotes two choices of either choosing the subarray formed from first picked element till now, or expanding the subarray by choosing correct element respectively. So this is the code, and this is the code, and saying in the code below we'll use must pick to denote whether we must compulsorily pick current element. When must pick is true, we must either return 0, what the fuck, or pick current element and recurse further. We either return 0 or pick current element and recurse further if picker is false. Okay, but this guy is only used must pick. Where's the picker? Maybe mistype. If must pick is false, we have both choices of not picking current element and moving to the next element, or picking the current one. A little confusing. I'm not able to decipher what it's trying to say. It's saying we'll use must pick to denote whether we must compulsorily pick current element. When this is true, we must either return 0, okay, as it is saying, If this is true, we must either return 0 int I. Okay, if we have crossed the size of A. If must pick is false at end means no element is picked, and this is not a valid case. I don't like this solution. Public int maxable int nums int time equals nums dot length return maxable. I don't like it. This is most probably DP only, sliding the receptor. I mean, kind of DP plus cadence algorithm approach. It is. Need a good recursive solution. Not getting the point, man. Not getting the point. See, I'm only able to apply DP once I understand the recursive solution. Okay, so that is the reason why actually I'm wandering here and there. Yes, see, exactly. At first, I think the subproblem should look like max sub array int of a, int of I, int of j, which means the max sub array for I to j. In this way, our goal is to figure out what however, if we define the format of our format of the subproblem in this way, it's hard to find connection from the subproblem to the original problem. I can find a way to divide the original problem into subproblems and use the solution. Find a way to divide the original problem into subproblems and use the solution of subproblems to somehow create the solution of the original one. Yeah, see, okay, cool. So I change the format to this one, which means max sub array 0 to I, which must have a of I as the end element. So these guys at least know DP, but I mean, this feels like a easy one in a DP question, right? Easy question, easy enough question to be solved by DP. Like easy DP question. Like, to learn DP, I should be able to understand this. Like this is the question where I want to start learning DP. I feel like that. Leaving the Fibonacci series, obviously, this is the one. So we just thought of a subproblem solution, coded it, and got the answer. ODP of means he is thinking of a recursive solution. Then he created a table. Using that, he resolved it. So dp of I equals u of I plus dp of I minus 1 of I equals u of I plus, if dp of I minus 1 means it is greater than 0, then we'll keep dp of I minus 1 or we'll just add 0. If it is greater than that, then we'll do it, otherwise we'll keep 0 and also we'll keep the max. I'm kind of getting it now, like much like prefix sum. This solution a little bit I'm getting. This is much like a prefix sum. See, we used to, and at start of the dp we have minus 2, right? That dp minus 1, and it is not greater than 0. So obviously we are keeping we are like taking this a of I means a of I as 0. Okay, then we'll go to next and we'll check this one, and this one is 1, and this is obviously greater than 0, right? So like we were already at this one, we checked, now we are at this one and we have checked, right? So at dp of I minus 1 or 0, we are going to keep dp of like add a of I with uh, means 1 plus 3 we have done now, and we have got 1 plus 3 we have done, and we have in the dp we have got minus 2 at that place. Now we are at 4, looking 3, nothing much, we just passed. Need to dry run it, but I don't want to dry run it before understanding properly. It is just instead of like as I have added, it is just skipping the negative number, I believe. Fail to get the proper recursion. This one is my like kind of like my solution. Now I'm a little bit okay to see some solution in lines to my solution, and exactly like my solution. So it is being said like this is a DP, 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 and divide and conquer approach. Okay, we can read this one. First, let's read this one. Oh shit. Fuck. What I believe is like I have not done much DP question, but what I believe is like I need to come up with some kind of recursive solution in my mind such that I can draw out a tree first of all, and second of all, so that I will be able to see the overlapping sub problems and then optimize it. And I'll always prefer tabulation method in place of stack or recursive call. Maybe that also you can do, but yeah, I at least want to learn that as the second most reported solution of this question has said. How it should work. I always believed like it should be the case. task of finding a contiguous array is sure correct is as large as possible. For some formulation of the formula, we allow the empty subarray to be considered. By convention, the sum of all values of the empty subarray is 0. Each number in the input array will be positive, negative, or 0. The array contains all non-negative numbers. Then the problem is trivial. Yeah, sure. If the array contains all non-positive numbers, then solution of the subarray of size 1 containing the maximal value of the array or empty subarray if it is permitted. Sure. Several different subarray may have same maximum sum. Sure. Although this problem can be solved using several different methods and techniques, including brute force, divide and conquer, dynamic programming, and reduction to shortest path. Okay. This one here. Okay. A simple pass algorithm is solved sufficiently. Supposed by this way, a simplified model for maximum likelihood of estimation of patterns is digitalized image. This method of estimating the parameters of assumed probability distribution. Assume likelihood of function so that under the statistical model the data is most probable. Okay, we can leave it right now for now. Same. Okay. Then dice throws. No empty subarray admitted.
let's do this DP one. DP solution. This is more likely as I got, like, this is also cadence solution, and let's see if I can convert this one into cadence solution. So here we are taking this is our answer. We are taking it as a max of integer max, or dp of I, that is here our temporary variable t. So what we are doing here is here we are calculating our ts, adding up the current element, okay, and if t reduced to, like, it's less than 0, then we are making it as 0. Now here dp is our t, dp of I, and a of I is going to be the array, and if dp of I minus 1 is greater than 0, that means we are going to use dp of I, otherwise we are going to put 0. That's it. Yeah, this is same. This same. What's the point? Yeah, essentially we are like no need of this dp. Essentially we are just so that thing is done only using one variable. Essentially we are just using that. You can say essentially we are just using that dp's ith minus 1th element to store the things each time. And similarly we are doing, like, if it is greater than 0, that's fine. We are adding the current existing element and putting it to the dp. Yeah, got the point. But now, as per the first, like, see how he's doing it. At first I think of the sub problem should look like, which means in this way our goal is to figure out what max sub array is. However, if we define the format of sub problem in this way, so he got the sub problem like this. To understand his recursive approach. Similarly, how subsets are subloaded in other problems. That is correct. Yeah. We pick an element at index I, then all subsequent element in the array must also be contiguous. This means the recursion explorer validates arrays while maintaining its contiguity choices at each step. For each index I, we decide whether to pick the current element and of I or skip it. For index I, we decide whether to pick the current element nums of I or skip it. If we pick it, okay, each I we are deciding if we want to use it or not. If we pick it, all further elements will be used. If we skip it, we can explore either starting a new subarray from subsequent indices or simply ignoring the current index. Can we simply ignore the current index? I don't think so. This one element of subarray is already picked. At the end of the subarray has continuous expanding. Yeah, walkthrough. Base case is this. If I is greater than size and all. If I reaches exceeds size of array, yeah, correct. If must pick is true, return 0 because the sum of the subarray is valid. If must is pick, return a huge large negative to get the no subarray exists. Invalid test case. Invalid case, I mean, when must pick is true. When the must pick is true. Two options, either end the recursion here, contributing 0 to the sum. Include the current element you find recurs further. When must pick is false. Return max of sol a comma I plus 1 false. Two options, skip the current element and explore subarray starting from the next index. Solve a. Okay, I'll continue with other video, I guess. I'm not able to concentrate now.